All right, welcome everybody to the final week of school. We've got some interesting classes this week. Today I'm going to be talking about one of the most important skills in computer science, which is the ability to copy and paste, plagiarize, and but in a legal and ethical way. Okay, so it is normally illegal to turn in other people's work as your own, because the whole point of a class like this is that you're learning the basic skills. Like, you know how to write a for loop, you know how to write a function, you know how to do an if statement. And if you're just turning in other people's work, you're not doing the mental work yourself, and you're not learning anything. And then by the time it becomes second semester, third semester, you're so far behind what you're supposed to know that you will fail even with the help of ChatGPT and other things like that. So, but the thing is, like, computer science as a whole is built on copying other people's code and appropriating it and modifying it and making it your own. And so that's the skill that you're going to learn today. Okay. So I have three exciting new homeworks that are available for you guys that I'll go through. And you're going to be able to choose which one of these three exciting new homeworks you are going to do for your final homework in this class. And two of them at least will involve being handed code that works, and then you need to make it do something similar but different. Okay, so let me pull up the first example for you. So here is it's all lined up properly. So here's a map of the world. And on the map of the world, I have the 500 most recent major earthquakes in the world. This is starter code from the Bridges people. So there is a 5.1 here in California on August 20th. November 8th, there's one in Western Texas. Morocco had a 6.8 in September, et cetera, et cetera. It's just color-coded based on, I think, latitude. I don't think it's anything crazy. Maybe latitude and longitude combined. You could color code them based on the magnitude and things like that. So here is working code. Here is code that I'm handing you that draws a map of the world, and it puts dots on it based on their latitude and longitude coordinates, and color codes them based on, in this case, just their latitude and longitude, but I could color code it based on their magnitude or whatever. And it has a little label that if you message over it, it tells you where the earthquake is. In this case, the central mid-Atlantic range, which had an earthquake back in August. You're up here in Iceland. There was a 5.1 and a 4.8 within the last couple months. And then there's a bunch over here in good old Yokohama, 6.0. Last time I went to Japan, there was a major earthquake there, and it actually killed a couple people. So here's working code. Your job, if you choose to accept it, and remember there are three options, this is just one of them, is you will have to take this code that displays earthquakes and puts pins on the map, basically. And you will have to get a CSV file of the top 100 or so cities in the world and display them on the map. So you're going to need to, A, find a CSV file that has, latitude and longitude. That's the most important thing. But the name of the city, the population, the latitude and longitude, and that's about it. And then you have to take this code and manipulate it so that it will display, instead of earthquakes, it'll display cities around the world. You guys understand? Do you see why this is like the assignment for today? Like, you don't have to figure out how to draw an overlay. You don't have to figure out how to color something. You don't have to figure out how to put a pin on the map at this location. All that is done for you. There's code there that will do it. Your job, instead of writing it from scratch, which some of the students tried doing in lab time, the 12 o'clock class, like, well, I'll just start from beginning. No, don't do that. What you do is you go into, let's see here, become Olson and see into Bridges map. What you do is you look through the existing code And this is code provided by the Bridges people. I didn't write almost any of it. I modified some of the stuff. I put in this here. So put your name here, put your API key here. You guys remember that from the Bridges thing. It won't compile unless you use the makefile. And if you do pull this line out, then remember you have to compile it using the makefile. You can't compile it just by typing compile. Now, here we're coming to the interesting part. So we've got a vector of earthquakes, and every earthquake, USGS, is a object that holds things like latitude, longitude, color, name, so on and so forth. And we are going to manipulate this. We're going to change it. We're in fact still going to have a vector of USGS earthquakes, but instead of displaying earthquake information, you are going to replace the code here. Do you see the dashed lines here? You're going to pull that chunk of code out and instead open up a CSV file that you guys have to find. I'm not providing it to you. You have to open up a CSV file and basically fill the vector with earthquakes that are actually London, Moscow, New York, LA, things like that. You guys understand? So it's and I've made it very clear what you need to pull out and where you're gonna replace your code with. You guys have done CSVs like 3 or 4 times now. Pokemon Part 1, Pokemon Part 2, data science. I don't remember what else. Where you use getLine to grab a line of the CSV file, you split it by comma, you throw away the header file, all that kind of stuff. And basically you're just going to extract the name of the city, its latitude, its longitude, and its population. And then you're going to put that into a new earthquake. And I even have an example for you here. We're making an earthquake named Bob. And Bob has a longitude and latitude of just some typed in random numbers. That's not real coordinates for anything. The name of it is New Orleans, Nolans for short. And the magnitude right now is a 6.5 earthquake, but that could represent 6.5 million people or something like that. Do you guys understand? Or you just type 650,000 or whatever into there. And then once you have the city, you add it to the earthquakes vector. And then if you do it right, the rest of the code should just work. And you don't have to understand anything about what all this is doing, right? You've just switched out one little piece of code. So instead of loading data where Bridges is currently actually loading data from the U.S. Geological Service. It's actually loading. There's actually a data source that will give you real-time earthquake information. It's pretty cool. Bridges is pretty neat. So instead of getting earthquake data, you're going to get data from a file and then just kind of do a switcheroo and then have the rest of the code be the same. So that is the power of copying and pasting. That's when I teach game development, I have all my students do a mod. And I have them do a mod because A, it's easier to just kind of tweak something inside of a game rather than, coding a giant game from scratch. But B, you also get to see how things are done. So before I did this assignment, I had no idea how the Bridges people did that overlay, how they displayed the overlay of the world map on top of the point data. And so when I found their example here, I scrolled around and I'm like, oh, look, right here, set map overlay, set coordinate system. That's how you do it. And then I learned how to draw that, how they did it, how it's done in the Bridges code. So rather than me hitting up the documentation, which doesn't say anything about it, right? If you look at the Bridges documentation, I wanted to know, how do I display the world map, right? So if we go to Bridges and we hit up the documentation, go to C++, and this is a set map function here. Set map, Bridges, set map, there we go. And so it says, this is an array describing the map overlay. The first element is either the world or the US, and the second element is which attribute from the map to show. A country from the world map or a state from the US map. Note that all is not actually mentioned there. And so like I was having trouble, like, all right, I want to show all of it. Like, how do I do this? And it's not on the documentation, right? This is very normal in computer science. So what you do is you look at how they actually wrote code using it, and you're like, there it is. It's all. I put in a blank string. It didn't work. It didn't display anything. So I'm like, oh man, how do I draw this thing? And so rather than hitting up the documentation, which is, what a lot of professors will say is your first thing, you should always hit the documentation up. A lot of times the documentation, it doesn't have the thing that you're looking for in it. And so the best way of learning how to do something is to see somebody who's done something similar and then be like, right there, that's how it's done. And then you can make your code work. Okay? You guys understand? Coloring it, there's demo code for coloring it here. Setting the location, this is the important part, right? Setting the longitude and latitude. But the thing is, like, all this code should just work. Like, you shouldn't actually have to really modify any of this except maybe the coloring. Like, I think maybe in the README file, I have you, like, color the cities differently based on their population or something like that. But basically, if you can just switch out the data source from here with a CSV file, all the rest of the code should work. You should be able to visualize the top 100, top 200 cities in the world. Boom. Like, with not too much effort. Not too much effort. It'd be a lot more effort doing this from scratch. And that's why we start with existing code. Okay? Any questions about that? Looks good. Option number 2 then. Option number 2 is making a graphing calculator. Okay? And so again, I have given you demo code. And this demo code I wrote at 2:30 in the morning last night. That's why I got my coffee here. This demo code was not code I knew how to write. I did not know the Bridges API interface for drawing like curves and things like that. So what did I do? I found an example they had that would draw a curve. And I'm like, aha, that's how you do it. Unfortunately, the only example they had was in Java. And so they didn't have a C++ version of any of the demo code that I needed. And so I had to read the Java code and mentally translate Java code into C++ code. And it worked. So you can see down here, what we're doing is we are visualizing a sine wave. And I'm giving you code that works. I'm giving you code that will successfully visualize a sine wave starting at x minimum, which I believe right now is set to -2, going up to x maximum, which is 8. Every step is 0.3. So what it's doing is it is running a calculation. X equals -2, x equals -1.7, x equals -1.4. Computing the value of y at every point. And then this guy here, polyline, which I'm calling poly, is a vector of points. And then when you graph it, it just draws a line between all the points. Done. Really easy. So you just keep going push back, or what they call it add point. You're basically pushing back a point over and over again into the polyline. You have to tell it how wide a line to draw, what color to draw it in. I spent more time, I think, picking out colors than I did actually coding this thing. Because this whole thing, this is the entire thing. It's just like a page or 2 of text. Like that's the whole assignment. Yep. And so yes, I have a color called Papaya Whip. I have a color called Dark Orchid. I had sea foam or seashell or something like that in there. Here's some of the colors: linen, olive drab, pale goldenrod, chartreuse, chocolate, cornflower blue. I was having too much fun just like looking at all the different shades. And here is what it actually looks like. Okay. So this color here, that is Papaya Whip. If you ever wanted to know what color Papaya Whip is, that's your color right there. Okay. And so what I've done is I've drawn a y-axis, I've drawn an x-axis, and I drew a little point of radius 0.1 as sort of like for scale, so you can kind of like see how big everything is. And you can see here that the sine wave is starting at -2, going up to 8, which is a little bit past 6, right? Surprisingly bland Yeah, I don't know. Okay. Then we got royal blue. It's a nice, pleasant blue color. And then what is that? That is like medium aquamarine or something like that. Yeah, medium aquamarine. Normal aquamarine is too bright. Like, forget about it. Like, it was hurting my eyes. But medium aquamarine is fine. And the dark orchid, which is that purplish color there. Okay. And so basically, all I'm doing for this graphing calculator assignment is I am pushing a series of points into a vector and then visualizing it. That's it. So all the rest of the stuff here, this draws the x-axis, this draws the y-axis, this draws the circle. I set up some constants, so the thing simulates from -2 on the x-axis to +8 on the x-axis, -2 on the y-axis, +2 on the y-axis. And so set viewport controls the rectangle that it draws by default. You can zoom in or zoom out or pan around, but that's kind of the default area that it draws. And then, then I just draw the axes, I draw the circle, then I do this. So what you're going to do is basically switch out that line there. Okay, so that line there that has y equals sine of x, you're going to replace that with a polynomial equation. Okay, so what you have to do for this assignment is take my existing code, which again is working, like this is working code that you can use and modify. And instead of graphing a sine, you're going to graph a polynomial. Okay. So do you guys know what a polynomial is? Like x squared plus 5x plus 3. Like, you guys know what a polynomial is? A polynomial, a single variable. I should make that clear. Single variable polynomial, which is like 5x squared plus 3x minus 7, something like that. Okay. So basically, the user is going to enter a polynomial, and then you graph it from -10 to +10. That's it. Okay. Would you have to write your own function to represent the y-coordinate? Well, I mean, you're basically going to do this, right? Except y is going to be equal to the function, right? So if the user types in 5x squared, you say y is equal to 5x squared. And x ranges from x minimum to x maximum. That shouldn't change. That shouldn't change. You're going to change step. I think you're supposed to change step to like 0.01. That change is something all of you guys should be able to do at this point. Change a value. There you go. Cool. Change x min to -10. Change x max to +10. You should be able to do this. The question is, how do you input a polynomial? And this is where the difference in grading comes in. So if you hard code the equation, you will get a 6 out of 10 on this assignment. You could also probably get it done in the next 5 minutes, right? Because you just go okay, well, y is equal to x squared plus 5 times x minus 3. There you go, graph it, done. Screenshot, send it. You have to do, I think, 3 equations. Whatever. Okay, that's 1. All right, next up, x cubed. And every time you do this, you should change the project ID, because the project ID is like a save slot, right? And so if you upload it again into the same save slot, it overrides the other one. And so you're going to need to send me on Canvas 3 links. One for the first polynomial, one for the second, one for the third. And if you keep the project ID the same, it's going to overwrite the same save slot over and over again. So after you do your second one, then change it again and do it again. And then you send it to me and you get a D. Yay, nice. Easy. You should be able to do that in less than 5 or 10 minutes if you just don't care about getting an A. Okay. So what do you need to do for a B? If you want to get a B on this assignment, basically prompt the user for the coefficients. Instead of a 5, hard-code it in, ask the user, what do you want the coefficient to be for x squared? Okay, 3. Okay, cool. What do you want the coefficient to be for x? 7. What do you want the constant to be? 12. And then you graph it. Okay, that's a B. And that's like an extra 10 minutes of work. I don't know, something like that. So you should be able to knock a B out of the park by the end of class today. For an A, it's a little harder. So if you want to get a 10 out of 10 on this one, you need to be able to parse the user typing in any polynomial, single variable polynomial with x. You know, it's not like you have to do like x squared plus y squared or anything like that. No, just, you know, x cubed minus 4x squared plus 9x minus 2. Any polynomial can be typed in. And in order to do that, well, I'll let you think about how you want to hold that. You can do a vector. You do a class. I'll let you think about that one. It's a little tricky. It's a little tricky. But the B and the D on this one should be pretty easy. Getting an A, be able to parse any single variable polynomial with x. No e to the x, no log x, no, just of this form, where you have a coefficient and an exponent, and x, right? So, x to the 0. I don't know if you need to support that. But something like this. Like, the user should be able to type this exact string in like that, and your code parses it and says, okay, and then it simulates it from -10 to +10, graphs it, done. Fractional exponents, no. Squared, cubed, 4th power, 5th power. By an A, I mean 10 out of 10. Yeah, and this is in the README file. So the README file at the very bottom, 10 out of 10, if you can graph any valid polynomial. 8 out of 10 if you have a limited input system, or like you just prompt the user like, enter the coefficient for x squared, enter the coefficient for x, enter the coefficient for the constant. You know, that's not a general polynomial. You can't do 10 times x to the 10th, right? But it might make it easy on you. One of the students in my earlier class did that, and they did it pretty quickly. And if you really want to just like get some points and call it a day, 6 out of 10, I don't know, hard code it, done. Yep. Okay, so do you guys understand? Again, this is demonstrating the principle of being given working code and then tweaking it and modifying it, like layering something on top of it, which is an incredibly crucial skill for a computer science person. Do you guys understand? Like, okay, like I wouldn't know how to do a polyline from scratch, but now that you've given me a polyline, I can figure it out. Right? Do you guys understand that mentality? And this is how computer science works. Like, legitimately, when I was writing this for you, I didn't know, you know, I didn't know that I needed to call set stroke width, for example, right? I just tried rendering my polyline and it drew nothing. Because guess what? Stroke width defaults to 0. Or maybe it doesn't. I don't know. But the color also defaults to white. And so when I was drawing this polyline and nothing was coming out, and I'm just like, why am I seeing nothing? You know, when you see nothing, it's very hard to debug, right? Is the thing too small? Is it what? And so you have to find, a lot of times, you just have to find somebody having something that'll draw something. And then once you have something, you're like, oh, I see. Yeah, I need to make this blue. And then it'll show up, right? When it was white, it's just invisible, fades into the background. Okay. This is like in all honesty, this is one of the best skills I can teach you guys, and it's literally a skill I used last night when putting the homework for you together, right? So, it's kind of like cooking. Most of the time, you aren't making everything complete from scratch, right? Or you might take a recipe and then tweak it, right? Like if somebody if you find a recipe for making creme brulee, right? And it's like, cool, it makes like one little terrine of creme brulee. but you've got 8 people coming over, right? You're like, okay, well, how am I going to do this, right? Like, I can multiply all the ingredients by 8, but like, do I have a tureen that I could like caramelize? Like, you sit there and think about it, like, okay, well, I've got this, and you like modify it, right? So you take what you know and then kind of mutate it into something you've never done before, and that's like 99% of computer science. So for this assignment, and for this assignment only, not on the final. Final, by the way, is going to be in finals week. It's going to be live. Make sure you are here during the final hour. But for this assignment and this assignment only, ChatGPT is allowed. I will allow you guys to use ChatGPT as much as you want. Any sort of generative AI technology, knock yourself out. If you can get it to make this for you, more power to you. I don't think it can. I think it's a waste of time, but it might be interesting for you. I don't know. If you do use ChatGPT on it, put it into your report and tell me how the experience with it went. Because I'm relatively confident, because I tried it, I'm relatively confident it does not know how to use the Bridges API. Like it's never. I don't think it has any training data on it at all. And so, like, when I tried it, it's just like, go to the Bridges website and read the documentation. I'm like, cool, thank you. Not helpful, ChatGPT. You're telling me what I already have done. All right. Just go to the website and get an API key. I'm like, cool, yeah, I've done that already. How do I make a polyline work? It's like, read their documentation. I'm like, thanks, AI. Thank you. That's So yeah, you are welcome to use ChatGPT. Yeah, you have more faith in yourself. You are welcome to use ChatGPT as much as you want, even if you're just kind of like curious to see if it's going to be able to help with it. My suspicion is it'll be a net negative time cost. That's just me. Yeah. So the final one that you guys have to do is called Bridges Mountains. And if you guys like cheating, this is for you, because the CSI 26 students have been given the answer to this. In CSI 26, the starting point, that's third semester computer science. The third semester computer science students have been given your answer as the starting point for their code. So you're starting here, and you have to get to here. They were given the midpoint, and they have to go to the end zone. And so if you want to cheat, which I don't recommend because it is cheating and you'll get a 0, you can ask the CSI 26 people for the answer, and then when I run the similarity detection, it'll flag it. Last year, some students thought that if they disguised it, that the cheat checker wouldn't pick it up. So when I said this in the previous class, they're like, so how do you check it then? Like, you're really curious about that, huh? Like, last semester, 2 students got thrown out of the program because they used ChatGPT, and I told them to knock it off, not do it again. And then they did it again, but they changed the variable names. I'm like, bro, there is no. Yeah. Maybe computer science isn't. And they're like, oh, I'll add some white space. Look, the professor won't be able to tell I copied now. It's like, yeah, maybe computer science is not the right major at this. Genius. I'm demonstrating my networking skills by asking others. Yeah. So just be aware there are answers for this out there, and the similarity detector will be run on this project. If you're not getting my sarcasm, don't cheat. Okay. So yep, username, API key, usual stuff. Okay, now this assignment is pretty fun. And what it is it is doing pathfinding, sort of. It's a low rent version of pathfinding. So basically, in CSI 26, you're going to do full pathfinding, where it can solve mazes and like go around walls and things like that. Here, it's a little bit less complicated. Okay, so let me zoom in. Okay, so the user is going to pick a row that it starts on. In this case, 200, I think. And let's get that out of the way. Starting row. Wow, that's really okay. Whatever. I think it's like 200. Okay. Now, what happens is every time you move east. You move east one step at a time. This is a giant 2D array filled with height data. And so sea level is represented in black, and the highest altitude is represented in white. Okay? And the rule is, as you move along these routes, let's see if I think we got some more examples in here. As you move along these routes, the rule to follow is you have to move to the square that is nearest in elevation to your current spot. Okay? So you can see that there's like, yeah, this is pretty good here. Okay. So you see how there's like this like river valley here, right? So if let's say you're like here right now, right? Yeah, there. You look at the square to your east, you look at the square to your northeast, you look at the square to your southeast. Those are your three options. Every time you move, you have to move east, and you can only move north or south one square. So there are three possibilities for you to look at any point in time. And you have to move to the spot that is nearest in elevation to your current spot, not the lowest elevation. A lot of students make that mistake.
I do. Where's Louis on the couch?
Okay. And
where's Louis on the couch?
I let him in. He's
Oh, we're doing that shit with the game?
Yeah. They have fun with it. They love it.
They do? It doesn't look like last time they didn't have fun.
They love it, Ada.
Yeah.
They're
good luck.
At least this year you guys have three options. So if you don't want to do this one, you can do one of the other two. Before it's just a line. So here's how it works. You're at one of the squares, let's say, and you have to move east. So what you do is you take the absolute value, the difference in elevation to the east, to the northeast, to the southeast. So let's say my current elevation is 1,000. And to the east is 1,010. To the northeast is 2,000. And to the southeast is 0. The difference in elevation to the east is only 10. Because I'm at 1,000, east is 1,010. And so that is the smallest change in elevation. So I take one step east. And then I repeat. And you just keep repeating all the way across the world until you hit the right edge and you stop. That's it. So you have a 2D array. It involves pointers. It involves row major ordering. It has a 2D to 1D mapping in it. The way that I recommend doing it is actually rewriting their code, which has a 1D array of all the height data in it. I actually just rewrote it as a 2D vector. And then it just was very simple. It's like get the spot northeast, east, southeast, which one's closer? Move there, repeat. And it's yay big. What makes it challenging is that it's got pointers in it, it's got arrays in it, it's a 1D array. The actual algorithm itself is not complicated. Because it's literally like, there's three numbers, which one am I closer to? That's it. Most common mistake, like I said, that students make is they just pick the one with the lowest elevation, and that's wrong. If you're on the top of a cliff, you do not want to go off the cliff if you can stay on the top of a cliff. You know what I mean? Like once we get to like a higher elevation, like right here, you see how it stays on the top of the cliff instead of going down into the valley again. It kind of stays on the top of the cliff because it's you die, right, if you fall off the cliff. But the rule is like just follow as similar in elevation as you can, and then you get these kind of cool paths going across the map. It's not a global optimization technique. You learn that in 26. It is what's called a greedy algorithm. A greedy algorithm makes locally optimal decisions, which doesn't necessarily turn into a maximally optimal solution, but it oftentimes does a good enough job. And in fact, if you see this here, you can see it follows like the river routes, and then once it gets forced to go up on top of a ridge, then it follows the ridge until it kind of gets forced down into a valley again. Then it follows the valley, then it gets forced up onto a ridge and stays up top, right? And so it does actually a decent enough job creating a path through Colorado. And this is actually Colorado GIS data. It's actually from I think NOAA is the website that produced all this data. I used to actually offer extra credit for students to make their own maps, but the website actually removed the ability to export things as text files. So yeah, so here you can see California, and it's like going up one of the cracks near us and crossing over that way. There's another one. You can see it kind of like it likes following these like east-west cracks as much as it can. So that is mountain bridges. So let's take a poll. How many students are interested in doing this one? How many people are interested in doing mountain bridges? The traditional CSI 40 assignment that I usually give at this time of the year. Two people. Go. How many people are interested? Show of hands. How many people are interested in doing the graphing calculator? This one. All right. Again, this one's easy to get a D, pretty easy to get a B, and it's probably going to be trickier than you think to get an A. No matter which option you choose, by the way, you're going to put all these into a Word document and submit the Word document on Canvas with a link to each of your project links on bridges, and also a screenshot of it, which makes it just easier to grade for me. Okay, 5, 6, 7 for 7 for the graphing calculator. And then how many people? What happened here? What happened to my overlay? The overlay's gone. Okay, there we go. Weird. And then how many people are interested in putting cities, like loading a CSV file and putting the basically hacking a earthquake, not simulator, but earthquake map. It's like a live earthquake map. If you ran this every day, you could actually see, like, you could actually have a magic mirror or something in your house that would actually show where the day's earthquakes were. And you can like look over and be like, oh, look. And, if you color code it for magnitude, you're like, oh my gosh, there was a giant earthquake in Siberia today or something, and just, only show the ones from the last like 48 hours or something. Color code them or make the sizes bigger based on their magnitude. But but for your assignment, again, no earthquake data, just get a CSV file, pull it up, put pins on the map for all the biggest cities in the world. Good to go. Chat, which choice is Freelo? What is Freelo? Okay, so we got a few for this one too. All right, so that is basically your options. You don't have to choose right now. I'm just kind of getting a feel for like who wants to do what. Disregard what my daughter said. She's trying to play mind games with you and psych you out so that you don't do the easiest one of them all. I don't know if they believe me. The Bridges Mountains one. You don't have to pick right now, but maybe take a look at the README file. The README file will kind of Explain what you have to do to get an A on each one. Your sarcasm detector is malfunctioning. Or is it? Okay, so take a look, and then you guys have until the rest of class today, basically, to try and get going on this. Okay, and is it counted as lab time? No, because on Friday we're going to do our final lab time. I'm going to teach you guys Java on Wednesday, and we'll go over the final on Wednesday as well. And then our last class, which is on Friday, we're going to actually have you guys write a Java program from start to finish, hopefully, by the end of class. So this will be due a week from today at midnight. So you guys got a week to do this, and I would recommend starting right now and reading over the README files. And if you have any questions, message me. And hopefully you guys understand and learn that skill that I'm trying to tell you, which is adapt, overcome, improvise. Wait, no, that's Bear Grylls. Take somebody else's code that does something similar, modify it, make it your own, and voila, you've done something cool. Okay, so that is it for lecture today. It is now lab time, beginning now.